Okay, let's talk about the cylinder then. The cylinder is a prism with a circular cross section. We want to find the volume of the cylinder. That's found by multiplying pi by the radius of the cylinder squared by the height of the cylinder. If we want to find the curved surface area of the cylinder, just bear in mind that from one point all the way around is 2 pi r. So if we were to open up, and this is the height, this is r. If we were to open up the cylinder and peel it apart and flatten it down, then we get this area of metal that is the can without the lid in the bottom, and the curved surface area is this part of the can, if you like, 2 pi r by h. 2 pi r by h. But the total surface area is this bit plus the top bit and the bottom, as depicted by this net here. So the total surface area of a cylinder is the curved surface area plus 2 times the area of this circle, or that circle. So here's an example. The volume of the cylinder is 1232 centimeters cubed. H is 8. Find r, the radius, using pi is 3.14. So the volume is 1232. Pi r squared h is the volume of a cylinder, is equal to 1232. So we put our values 8, and we don't know what r squared is. So r squared must be this divided by 3.14 by 8. R squared is equal to 9.04. R is equal to the square root of that, get the square root of both sides. R is equal to 7 centimeters. Question 15, page 343. Rain falls into a flat container. Here's the rain falling in. That's 88 by 42 by 6. When it's full, it's poured into an empty cylinder of radius 21. The depth of the water in the cylinder is h. What is h? Okay. Well, the first thing we need to do is find the volume of water collected, and that's basically this volume of this tray here, which is equal to 22176 centimeters cubed. Now this is the volume of the water cylinder that's created, which has a radius of 21. So the volume is equal to pi r squared h. So we know what pi is, we know r is 21, we're looking for h, and that's all equal to this volume here of this water cylinder, okay? Here it is here. And this is the h we're looking for. It's 21 there, it's 21 there, it's 21 there, the radius. So if that's the case, then we have to rewrite it so that h is the subject of the formula. H is equal to 22,176 divided by, bring these over here, pi times 21 squared. H is equal to 16 centimeters. Okay, let's look at the sphere and the hemisphere. Here's the sphere, the ball, radius r. The volume of the sphere is 4 over 3 pi r cubed. The surface area of a sphere is 4 pi r squared. And if we have a hemisphere, then it's kind of half the ball with radius r. The volume of that is 2 over 3 pi r cubed, and the solid surface area is 3 pi r squared. So here's an example. A sphere, a ball, of radius 4 is dropped into a cylinder partly filled with water. When the sphere is completely submerged, the level of the water rises h centimeters. If the radius of the cylinder is 8, find the value h that this water level rose. Okay, so just try and visualize it here. You have your cylinder, okay, of radius 8, and you drop the ball in, which is radius 4, and there's this amount of water displaced, so it rises h. So the volume of the sphere is equal to the volume of this water displaced, has to be. So 4 pi r cubed is equal to pi r squared h, volume of the sphere, volume of a cylinder. So 4 over 3 pi by the radius of the sphere is equal to pi radius of the cylinder, which is 8, h. So the 4 over 3, the pi's can cancel, and you have 4 over 3 by 64 is equal to 64 h. H is equal to 4 over 3. H is equal to 1 and 1/3 centimeters. Okay. Another example. Three tennis balls of diameter 6 centimeters just fit into a can. Okay. So 1, two, and they're squeezed tightly against each other. Just for the can. Finds, in terms of pi, the volume of the tennis ball. Well, the volume of a sphere is 4 over 3 pi r cubed. The diameter is 6 for the ball, so its radius must be 3. So you just plug in your 3 by 3 by 3, your 3 cubed, 4 over 3. That one of those will cancel. So you have volume of the ball is 36 pi. The volume of the can in terms of pi. So we're not putting 22 over 7 or 3.14. We're not messing around with any of that. We're just going with the formula. The volume of the cylinder is equal to pi r squared h. That's pi by, again, if the ball is 6 in diameter, the radius must be equal to 3. Okay, for the cylinder, 3 squared by the height is 18 because you have 6 plus 6 plus 6 in the can. Okay, so that's pi by 9 by 18 is 162 pi. So the volume of the space in the can then, this stuff that's left over, the thin air surrounding the balls, must be equal to the volume of the can minus 3 times the volume of one ball. So it's 162 minus 108, and that's equal to 54 centimeters cubed. Now another example, question 13, page 347. A sphere with radius of length 3 has a volume equal to 8 times the volume of a sphere with radius r. Find r. So this one with a sphere with radius of length 3 is equal to, has a volume equal to 8 times the one with r that we don't know. Okay, so we equate 4 over 3 pi r cubed to 8 times 4 over 3 pi r cubed. These will all cancel out, 4 over 3 pi's, they're gone, leaving r cubed is equal to 8 r cubed. Now we know it's 3 in this case, so it's 3 cubes equal to 8 r cubed. 3 cubed is 27, divide both sides by 8, so 27 over 8 equals r cubed. So r must be equal to the cubed root of 27 over 8, it's equal to 1.5 on your calculator. Okay, let's talk about the cone. So here's a cone, okay, and it has height h and radius r and length l, and you can find L squared. L squared is equal to h squared plus r squared, should you need to. Anyway, it's a right circular cone. Why is that? Because its vertex is directly above the centre of its base. So it's known as a right circular cone. The volume of that cone is a third pi r squared h. The curved surface area of the cone is pi r l. So if you need to find L, you use this, Pythagoras. L squared equals h squared plus r squared. And the total surface area of the cone is pi r l, which is the curved surface area, plus pi r squared, which is the area of that circle that it sits on. So a solid, here we go, a solid metal cylinder of radius 5 and height 12 is melted down and recast into a cone of base radius 10. Find the height of the cone. Find the h. So the volume of the cone is equal to the volume of the cylinder. Pi r squared h is equal to the volume of the cone. So a third pi 10 squared h is equal to, plug in your dimensions 5 and 12. So we get pi will cancel, which often does. We have 100h over 3 is equal to 25, 5 squared is by 12. So h is all of this times 3, bring that over and divide it by 100. H is equal to 9 centimeters squared. Okay. Now, example, question 12, page 351. The volume of a cone is 512 pi divided by 3 centimeters cubed. The height of the cone and its radius length are equal. Okay, find the length of the radius. Well, the volume of the cone is given by a third pi r squared h, and that supposedly is equal to 512 times pi over 3. But r is equal to h, so we could write this as a third pi r squared r is equal to 512 pi over 3. So we can cancel our pi's. Okay, we have 512 over 3 is equal to r cubed, r squared by r cubed, all over this 3 here. So if that's the case, then r cubed must be 3 times 512 divided by 3. So r is equal to the cubed root of 3 times 512 all divided by 3. That's equal to 8 centimetres.